What's so great about Python? Well, the list is really long and varied. Let's start with Python containing all the different major programming idioms. So Python is great for building object-oriented applications and architecting your application that way. There's a very rich type hierarchy, even has multiple inheritance, which, may or may not be a good thing, but you can model things using objects super well in Python. At the same time, you don't have to use objects, unlike languages like Java and C#, where it's only object-oriented programming, like everything has to be a class, and you can kind of shoehorn out other models. You could just work in functions. So this procedural style is totally good. And there's also a functional style of programming, which works with things like immutable data and passing functions and all of those ideas from the functional programming languages. And you even have things like aspect-oriented programming with things like decorators in Python. So you can model or work in whatever way suits you. And Python runs everywhere. So Python obviously runs on the major platforms, Linux, Mac OS, and Windows, but it also runs on things as small as Raspberry Pis or even microchips. There are special microchips that run a flavor of Python called MicroPython. And these are like $5 microchips, and yet you can take Python and it is more or less the OS for that little chip. You can even do wild things like hook function callbacks up to, say, a hardware interrupt. How about that? So in addition to all of these programming models, we have a very simple and easy to learn, easy to read programming language. And the icing on the cake is really what you'll find at what's called the Python Package Index, or PyPI. At PyPI, there's over 120,000 external libraries that are one line on the command line to install, and you can do amazing things. You can install deep learning models or image recognition models or web frameworks. The selection of these various libraries is amazing, and one of the challenges of learning Python is actually learning those libraries and which ones work well with others. And there are sites out there to help you with those kinds of things, but it's really a huge benefit that you don't just get the language, you don't just get the standard library, you get the 120,000 plus other packages out there to help you build your Python application. Why is Python a great language for beginners? Well, the language is super simple. And in fact, you could probably learn the basic syntax of Python in a weekend. It's one of these things that you can learn right away, but it takes a lifetime to master, sort of things. But because Python doesn't force all of this formalism on you and all of this structure, you can use just the little pieces that you need. Maybe you don't know how to work at all with web frameworks or databases or decorators or list comprehensions or all these advanced language features. You can just pretend they don't exist. You can just write your simple little program. You don't even need functions if you really don't want to, if that doesn't make sense for you. So as you need them, you bring in these language features. And this is one of the reasons that Python is the #1 first language for computer science students. This is across universities in the United States. This is also true generally throughout the world. If you look at people learning computer science, these days they're learning on Python and then they move away from there because all the major concepts can be taught on Python without all the headaches. It's beautiful. Why do expert developers choose Python as their preferred language? You might think this simple language, easy to get started language that's great for beginners is not going to be that great for experts. You'll outgrow Python. And that's one of the magical bits of Python is typically you don't outgrow it. You just bring in these richer and richer features into your application that maybe the beginners didn't use. So if you look at some of the major applications that are out there, they're built with Python. We've got the question answer site Quora, one of the major sites around Q&A on the internet. We have Dropbox, front end stuff and back end stuff. Even that little icon in your taskbar or your notification center, that's Python coming from Dropbox. And we have YouTube written in Python. YouTube actually gets several million requests per second, and it's totally handled in Python. So while Python starts small, its ability to grow is really kind of special. And this has somewhat to do with the language having a simple but not simplistic style to it. You can bring in advanced features, but you don't have to. And the 120,000 packages on PyPI that you can just go and reference. It's also super, super popular in data science, machine learning, deep learning, a lot of those things, TensorFlow, Keras, these are all using Python in major ways. And on top of this, Python is one of the fastest growing languages out there. According to a Stack Overflow sort of analysis that they did in late 2017, this is one of the fastest growing major languages by a long shot, and it's much more popular than really shiny new languages like Go or Rust. So you can see across the board, Python is widely used by professional programmers for applications that require the highest demands, like this YouTube.
So you've heard some of the benefits of Python. Let me tell you some of the drawbacks as well so that you know what you're getting yourself into. Python is a great language and it's very fast to read and understand, but it's not designed for speed of execution. There are other languages that can help you squeeze those last little bits of performance out of the computer if that's exactly what you need. Most times that you use Python, though, for like web development and things like that, you don't need to squeeze every last bit of performance out, so it's not actually a problem. Python also doesn't run natively on web pages. That's the only language that does that is JavaScript. Now you can do web development with Python, and many people do, but that means running Python on the server side. On the client side, you still need to run JavaScript. Similarly, Python doesn't work for mobile applications either. You can run it on the server side for the service part of your component that works with the mobile app, but the mobile app itself has to be written in either Java for Android or Objective-C or Swift for iPhone. Python's also not really designed for embedded systems. It's, again, designed to be easy to understand and easy to write rather than being super tiny, super fast. There is a version of Python called Embedded Python, which is designed for that, but it's a sort of stripped down version of the language. And the other thing about Python is that there's a version split going on between Python 2 and Python 3. Python 2 is an older version of the language that's been around for much longer, and there's a lot of code that's compatible with it. Python 3 is a new iteration that makes some changes that are incompatible with the old version. So if you have code that's written for Python 2, it may or may not run properly on Python 3. This is something that the whole Python community is sort of working through over time, and nowadays Python 3 is clearly the path ahead, but it's just something to be aware of that there is a difference between Python 2 and Python 3.
Tips for making installing Python as seamless as possible? Well, Python itself is actually quite easy to install. If you're on Mac OS, you can use brew, just brew install Python. Be sure to get Python 3 on all of these, not the older Python 2 if at all possible. On Linux, you can install a Linux package, so apt install Python 3 will install Python 3 for you, but luckily it actually ships on many of the Python distributions that are the latest ones there. And on Windows, there's an MSI installer, and this used to be not so great, but the guys over at Microsoft have done a really great job to make installing Python on Windows easy and not even something you have to be an admin to do. So where Python gets really interesting and sometimes tricky is installing the 120,000 or plus packages out of the Python package index. Usually they install just fine, but periodically they might require a C compiler or, God forbid, like a Fortran compiler, something really tricky that's hard to set up, especially on Windows. And so there's ways you can work around it, but installing Python, brew install on Mac, apt install on Linux, and just get the MSI and run it on Windows. Are there common obstacles to getting started with Python in terms of installing it? Then probably the biggest one is installing these packages. Installing Python itself, the runtime, straightforward. They have that handled on all the platforms. But of the 120,000 or more packages on the Python package index, they are all a little bit different. They have different dependencies. And when you install them, maybe it needs to work with Ruby to run some kind of script, or it has to do a C++ compiler, or maybe even it has to install something using, let's say, Fortran, like a compiler for a subsystem in some machine learning or astronomy piece has to maybe compile some Fortran. And do you have a compiler for Fortran on your machine? Probably not. I don't think I do. So that can be the challenge for installing Python, is really installing the dependent libraries. How do you get around this problem of dealing with tricky libraries that you have to install? Well, I would recommend the Anaconda distribution. So Python comes in many flavors. There's what's called CPython, but also PyPy, IronPython, Jython, all these things. And this is sort of the standard Python interpreter or compiler, depending on which one you choose, and then the standard library. And Anaconda goes a little bit farther than that. This is mostly focused on scientists and data scientists, but it's good for all of us. It lets you download hundreds of the most common libraries used in Python, pre-compiled into a binary form that you just drop onto your machine and run. No compilers, no compile step or slowness is required. So if you check out the Anaconda distribution, it vets and verifies and pre-compiles many of the libraries that you might want to use, and you can just instantly download them and start using them no matter how your machine is configured. Bunch of great tools there, so that's what I would do to get over the obstacle.
So here's an example of a very simple Python program. It just adds together 1 and 1 to get 2. You can see the actual code is right here, 1 plus 1. This is the results of the program, which is printed on the next line. The 3 carets that you see to the left of the actual code, that's not actually part of the Python program itself. That is simply an indicator that the Python interpreter gives you to let you know that it's ready for the next line of input. Here I've rewritten the last code example to show you a new concept in Python, variables. Variables are just a way of holding a value inside of a name for that value. So in this case, I've set the letter x to equal the number 1, and I'm doing x plus x, which gives the same result. It's 2 because it's 1 plus 1, just like the same program before. Now this is sort of reminiscent of, you might have done algebra in school, but unlike algebra, you can actually use variables that are a lot more accurate in their names to convey information about what you want. So here I have 2 apples and 3 oranges, and I'm adding them together, which you're never supposed to do, but in this case we can get 5 apples and oranges because apples is 2 and oranges is 3. You can have as many variables as you want, and you can use whatever names you want for your variables, which helps you to understand what your program is doing conceptually. The only restrictions are you can only use letters, numbers, and underscores when you're defining the names of your variables, and you can't begin your variable name with a number, because Python thinks that if it begins with a number, then it must be an integer, like 10 or 15. So aside from that, you can pick whatever names you want for your variables. When you write code in Python, it's organized into statements, where each statement is a single instruction to Python. The code that I'm showing here has 3 statements, this one, and this one. You can see that there's a line at the bottom which has the return value, but that's not a statement. That is Python telling you the result of the last statement. That it just ran. A statement is generally a single line of code. You can actually have multiple statements on a single line that just ran. A statement is generally a single line of code. You can actually have multiple statements on a single line of code, but that is very bad form. It's not Pythonic, as it's called. So generally, you can look at your program and see that each line is a single statement. Python completely skips over comments. As soon as it sees one, it immediately moves on to the next statement, so it doesn't affect the runtime of your code at all. But they're important for helping yourself and others understand how the code is supposed to work. A comment starts with a pound sign, this thing here, and continues on for the rest of the line. Anything after the pound sign is treated as a comment and is ignored. Notice that on this slide, I still have those 3 carets to indicate that this is a program running in the Python interpreter. Those don't count as the start of the line. Those are just an indicator that we're running Python. The line begins here, which is why we have the pound sign at the beginning of the line to indicate that everything else is a comment. programming language, including Python. Just like variables, functions have a name. However, functions are called by passing parentheses after the name to indicate that the function should be executed, not just referred to by name. Functions can also take a number of arguments, as they're called, which is values that modify how the function works. So here I'm showing you the print function, and I'm calling it in two different ways, one with no arguments and one with a single argument, the number 10. Either way, it'll print out a value, either an empty string or printing out the number 10. So far, you've seen one type of data used with Python, numbers. But Python can actually handle multiple different types of data. And another type of data that we should go into is called strings. Strings contain text, whether it's just a single character or volumes and paragraphs of text. A keyboard mash, anything that the user types into your program, those are all treated as text. Now, when you're writing text in your Python program, there are two ways of notating it. There's single quotes, double quotes, like this and like this. And there's single quotes, like this and like this. Either way, they're treated exactly identically, and you can see that the Python interpreter will show you the result, and it will show you the result using double quotes either way. That shows that they're interchangeable. It doesn't matter which one you use. In addition, when you have strings, you can combine them together in the Python interpreter by using a plus sign, and that will concatenate or combine the two strings together into one longer string. As you might imagine, the print function works with more than just numbers. You can also pass it a string, and it'll use that to display exactly what the string says on the screen. In this case, I'm using the print. As you might imagine, the print function works with more than just numbers. You can also pass it a string, and it'll use that to display exactly what the string says on the screen. In this case, I'm using the print function, just as we've seen before, but I'm passing a string to it as an argument. Notice that I'm using double quotes to say this is the contents of the string that I wanted to display. The print function will use that string to determine exactly what should be displayed on the screen. You can also store strings in variables, just like you can with numbers. For example, here we have a case where I'm storing the name, Jenny, into the variable name. You see, I did that just like I did with storing a number into the variable, but this time I'm using a string. I can also use that variable anytime that I would want to refer to the string. For example, when I'm doing print name. In this case, you'll notice that I'm referring to name without quotation marks around it. That tells Python that I want to look up the variable instead of literally using the string name. And I can use that anywhere that I would pass values to, including the print function, as we've seen before. So far, you've seen how to type Python code into the interpreter and have it execute one line at a time. But the problem is that it doesn't save your code when you do that. Python will execute the code, and the code will vanish into the ether. When you're writing programs, you generally want to save the code that you're working on so that you can access it and edit it later. The way to do that with Python is to save your code into a text file, usually called a .py file or a .py file. Let me show you how to do that. To start off, I'm going to open the command prompt and run a simple line of code that we've seen before. So I'll go into the Python interpreter, and I'll type print hello, just using the print function as we've seen before to print the hello statement, or the hello string. So if I wanted to save this code so that I didn't have to retype it out every single time, I need to use a text editor to create a text file. I'm going to use the Atom text editor, but you can use whichever one you want. I just happen to like this one. So in here, I'm going to type out, print hello, and then I will save this file. Save. It's going to ask me where I want it. I will call this hello.py. The .py indicates that this is a file that contains Python code. I'll hit save, and now you can see that my editor has highlighted this code in different colors so that it's easier to recognize it as a Python file. But that doesn't change the contents of the code. That's just my editor trying to be helpful. So now I'm going to exit out of my Python interpreter. And if I go over to my documents folder, which is where I have that file saved, I can see it's right here, hello.py. And now I can run Python, but instead of pressing enter, I'm going to pass the file as the second argument. So I'll say python hello.py. And this causes Python to execute the lines in the Python file one at a time, just as though they had been typed into the interpreter the same way we've been doing previously. So for example, I can change this, and I can type goodbye and save, like that. And now, if I run this again, now it says goodbye, because Python is just running the lines of code that are in this file. While you're writing your programs, you may find that you accidentally do something that causes the computer to raise an error or an exception. Something like referencing a variable name by the incorrect name, or while you're writing your programs, you may find that you accidentally do something that causes the computer to raise an error or an exception. Something like referencing a variable name by the incorrect name, or dividing a number by 0, or trying to read a file that doesn't exist on your computer. In any of these cases, the program will stop and show you a stack trace, as it's called, a listing of the various ways that things went wrong. And it'll explain to you exactly why it was unable to do the thing that you asked it to do. This is okay. Programs are designed to be able to fail like that and to not cause further issues. Raising exceptions is a normal part of programming, and it's something that you have to learn how to deal with properly. It's not something that's going to break your computer or cause it to explode or call the police, even if something says it's an illegal exception. That just means that it's not part of what the protocol is supposed to handle. So if you find yourself running into exceptions, I would challenge you to explore that and to learn more about what exceptions are available, what exceptions Python might raise for you, and even see how many different exceptions you can find. There's actually a fair number of them out there, and it can be kind of fun to see if you can find a new one that you've never seen before. Flow control is a way of writing a program that shifts and adjusts based on the conditions that it encounters. We're going to talk about flow control in Python, but it's a concept that can apply to any programming language. If you think about water flowing down through a river, when it goes through the current and encounters an obstacle, it doesn't just stop. It flows around that obstacle and continues moving down. That's what we're going to do in Python as well. We're going to use if statements to say, if you encounter something unexpected or special, then do something to flow around that special condition and continue on running. Here's one example of flow control in Python. It's called a conditional, or more simply, the if statement. You can see here we have an if starting us off. And that if is followed by a condition to test for. In this case, we're testing to see if the age is greater than 18. If so, we go into this indented body over here. And here it says, if that's true, then print adult. You can also have an else statement with your conditional for something to do if the condition is false. In this case, if the age is not greater than 18, then you're going to go into this indented section and display child. When you're using an if statement, it's almost always important to use some sort of comparison to determine if that if should be true or false. There are 3 comparisons that are very handy in Python, especially when you're dealing with numbers: less than, greater than, and equal to. You'll notice that these are exactly like the mathematical constructs. Less than is a caret pointing to the left, greater than is a caret pointing to the right, but the equal sign is different. You actually have a double equal sign to say that you want to check if two things are equal to each other. The reason for the double equals is because single equals is used for assignment in Python when you're setting a variable to a certain value. Single equals is assignment, double equals is comparison for equality. Here's an example of a simple loop in Python. Specifically, this is a for loop because you can see it starts with the word for. In this case, we're going to set up a variable called letter, and we're going to loop over the word hello. Within the loop, you can see that we're referencing that same variable, letter. Every time that this loop is run, that variable is going to be set to a different value. First, it's going to be set to the H, then the E, then the L again, and then the O. Because the word hello has 5 letters in it, this loop is going to run 5 times, and it's going to print out 1 letter at a time each time that it runs. Looping over the characters in a string is sometimes useful, but it's a very specialized use case. There are other things that we can use loops for that are much more generalized, and we'll get to that in the next video. Looping over characters in a string is all well and good, but most of the time you'll need something a little bit more general than that. When you're looping, the thing that you want to loop over most of the time is a list. Lists, as the name implies, can contain a list of multiple different items, and those items can be strings, numbers, whatever you want. A list can also have any number of items in it. 1, 2, 3, a million, could even have 0 items. To make a list, you use square brackets, the ones that look like these. And to put the values inside the list, you just define them in between the square brackets and separate them with commas. So here I have a list containing the numbers 1, 2, 3, and here I have a list containing the strings Alice and Bob. You can even mix up the values in the list, so you can have a list containing both strings and numbers in the same list. It's also sometimes handy to have an empty list, which just looks like this. It's a list that has length 0 and no values in it whatsoever. Lists are a natural candidate for looping in Python. You can see that this example looks rather like the one that we saw before, but this time we're using a list instead of a string. Similarly, we're setting up a variable, we're referring to that variable in the body of the loop, and every time that the loop is executed, it's going to be bound to a different value in that list of items. So first, num will be 1, and it'll print the number 1. Then num will be 2, and print the number 2. And then num will be 3, and it'll print the number 3. You can use any values that you want in your list, and you can loop over them and use them as you wish, just like a variable in any other context. You've seen some examples of using if statements and for loops. Let's see how you can put them together into a Python program so you can use them effectively. In this case, I'm going to write a program that's fairly simplistic, but uses these flow control statements in a way that might be handy for you. So I've got here a terminal on the left side and a text editor on the right side. And I'm going to write my code in the text editor and run it in the terminal so that you can see how it works. So I'll start by creating a file here. I will save this as flow.py. And let me start by making sure that it works. So I'll just do a simple program here, save it, and then I will go to my documents folder and do python flow.py. Yes, it works. Now let's start playing around with flow control. I'm going to set up 2 different variables for two different people. I will say that name1 is Alice and name2 is Bob. Now in this case, we want to identify who is who in terms of these 2 people. So I'll start by saying, let's see who name1 is, and then I'll check to see if they are who I think they are. If name1 equals Alice, then I'll say, you're Alice. Otherwise, I'll say, you're not Alice. It's a pretty simple check. Save it, run it again. And indeed, it knows that this first person is Alice. And we can try the same sort of thing with the second person as well. So let me see name2. if name2 equals Alice, just typing out the same thing as before. And save and run again. And indeed, the first person is Alice, and the second person is not. So we know that these if statements are working exactly the way you would expect. Notice that I'm using double equal signs for comparison here, rather than single equal sign. If I was using single equal sign, then that would assign this variable, assign the string Alice to the variable name2. I don't want assignment, I want comparison, which is what we have before. Let's also go into for loops a little bit. Let's say there are a couple of people that I want to loop over, and I'll say name1, name2, Frank, and Charlie. So now I have a list of names where that list is Alice, Bob, Frank, and Charlie. You'll notice that I'm referencing variables for some of the items in the list, and I'm using strings for other items in the list. And that's fine, because the variables are going to be resolved into strings when that list is created. So this is going to work exactly the way you'd expect. And we can verify that by saying hello to each of the people in this list. So I'll say for name in names, print hello, followed by the name. You can see I'm looping over each item in the list, assigning it to the name variable, and I'm referencing the name variable here. So I'll save this, and let me try running this again. And now, in addition to all the code that we had before, we're also getting 4 hello statements saying hello to Alice, Bob, Frank, and Charlie, which is exactly what we wanted.